All right, you guys, here we go with section 4.4. So these are infinite series, and we're going to talk about some important vocab words, convergent and divergent, which these are huge. You guys are getting really close to calculus. These are huge, important words for calculus. I feel like in college I had an entire semester class that dealt with convergent versus divergent. So an infinite series, we've talked briefly about this in class. It's a series with an infinite number of terms. So your clue here is these dots at the end where there's not a stopping point. You have a certain series and it goes on forever. Or if you see that infinity symbol above the sigma, when we talked about like that weird Greek letter sigma, which means sum, if there's an infinity on the top of that, that means it goes on forever. That's an infinite series, and that's what we're dealing with in this section. We do have a formula for an infinite geometric series. It's a little bit more simple than the formula that's in the previous section. Remember, that was for a finite geometric series, one that ended. In this case, if it goes to infinity, it's a much simpler formula, believe it or not. It's kind of a weird concept to wrap your head around in terms of like, wait, how can we add up an infinite number of terms? But I'll give you an example. What I need you to know is that a series that's something that's called convergent. It's as the number of terms gets bigger and bigger, meaning as we add more and more and more terms and write out more and more numbers of a certain series, the sum actually approaches a specific number. And this happens when the terms get closer and closer to zero. So you can notice for this example, these numbers are getting bigger. That means farther away from zero. This is actually a divergent series because these numbers are getting bigger and it's going towards infinity. Okay, so I'll give you an example of a convergent series, a very simple one. So an example just to jot down here, just in case you're curious. What if I took the series that was very simple that looked like this, and I continued it forever? And so you can tell already that I'm multiplying by 1/2 each time, so it's a geometric series. These numbers are getting smaller as I'm cutting them in half every single time, but you can probably start thinking about this in your head. What happens when you take 1 and 1/2 and add them together? You get 1 1/2, plus 1/4 means 1.75. Plus 1/8, we're getting closer and closer and closer to the number 2. So I encourage you actually to take your calculator and type these in and actually continue it a little bit more. Like the next term would be 1/16 and then 1/32, and add all those numbers up. And the farther out you go, the closer and closer the number gets, or the sum gets to a specific number. And in this case, the number is 2. How to use the formula with that? It's very simple. You just plug in the 1 here. So 1/1 minus the ratio. The ratio is 1/2 each time. So 1/1/2, flip and multiply, you get 2. And that's actually a really crazy thing to like wrap your head around, but we can actually add up a convergent geometric series, meaning if these numbers are approaching zero, getting smaller, you can actually add them all up forever. They approach a certain number. If you remember anything from Algebra 2, maybe you remember the chapter where you graphed a bunch of stuff with asymptotes. And remember how those were like dotted lines on the graph, and your graphs approached those asymptotes and ran alongside them and then had an arrow that like went up or down forever? That's kind of the idea that we're talking about here, is that the sum, if you continue this and get closer and closer and closer and closer to zero and you add up all these numbers, you're going to get really, 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 really close to the sum. So in this case, I should have written that down maybe. By using that formula, the sum of all of these numbers is 2. And that's from using this formula right here. Or by typing all these numbers plus a couple more into the calculator, you can see that it's approaching 2. Okay, so then what does divergent mean? Divergent mean the sum gets infinitely large. So here's a divergent series because these numbers are getting bigger and bigger and bigger. And you can see if I would add them all up, they would go to infinity. Like I would add up in an infinite number of huge numbers, I would have a massive number. They're not getting closer to zero, they're getting bigger. That means it diverges. And remember, the fancy way that we say that is that the sum does not exist, DNE. And FYI, arithmetic series, those always diverge because you're always adding a certain number to the next term or subtracting. That's why I put or small. You're either subtracting a number and it's going towards negative infinity or it's going towards positive infinity. So those are always DNE. Okay, let's do a couple examples. That was me talking a lot about this really important vocab, but let's try a couple examples here. This very first one I already did in red up here, but just for extra practice, you know that you're multiplying by 1/2, so that's the ratio each time. And note that these numbers are getting smaller. It's a geometric series that gets smaller. That means it converges. So that means I actually can use my formula, okay? So when it converges, you're allowed to use the formula. So a sub 1 over 1 minus r, the first term is 1, the ratio was 1/2, we already did this example, you get 2. That means if I add up all these numbers and go towards forever, the sum is exactly 2. If you add up these numbers, you can see it's getting close to 2. If you add 1 over 16 here, it's getting even closer to 2. If you add 1 over 32 here, it's getting even closer to 2. Okay, let's try another one. Again, these numbers are getting smaller, so that means it converges. Let's figure out what the ratio is. It looks like I'm multiplying by -1/3 each time. Yeah, the signs are alternating, so that's my ratio. And that means that I can use my formula, and I'm just using an s, not an s sub n, because I have an infinity here, so there's not an n number of terms, okay? So make sure you got that straight. I'm taking my a1 over 1 minus r. My a1 is 24, 1 minus -1/3. Be careful with that double negative. And yeah, that means that I will add 1 plus 1/3 is actually 4/3. And so that means I can flip and multiply. And that gives me 18. So again, what you could do in your calculator if you were like nervous about that formula or you wanted to like check your work or whatever, that's a 1/3 by the way. If you wanted to check your work, you could write out the first like 5 or 6 or 7 terms and actually type them into the calculator and they would be really close to 18. If you would do a bajillion terms, it would be exactly 18. If you would do the infinite number of terms actually. But you should be able to notice that it is approaching a certain number and that number is 18. Okay, how about this one? For this one, it's the sigma notation again, and so I think what might be helpful is to actually write out the first couple terms. So what I'm going to do is take my 1, which is the first term, and plug it in right here, and that's going to give me 2 times 1/3 to the -1, which is 2 times 3, which is 6. That's the first term. How about the second term? So if I plug in not 1 but 2 right here, that's going to give me 2 times 1/3 to the 0, which is just 2, which is the second term, okay? So what I can tell first of all is that if this is my first term and this is my second term, they are decreasing, so they are getting smaller. That means it converges, which means I can use my formula. And so I'm going to go right to just writing the sum formula, s equals a sub 1 over 1 minus r. And I found my first term up here, 6. So usually you're used to looking up here in the formula, but notice that this doesn't match exactly. So this is not the formula for the nth term. Just be careful about that. The reason for that is because they adjusted the starting point here by the n minus 2, and that's okay. You have the first term up here. You can always plug in n equals 1 to figure out the first term. So that's going to be the 6 on the top. And the 1 minus the ratio, what did I multiply the 6 by to get 2? 1/3. That's still the same number that's here, okay? And so what that means is 6 over 2/3, which means again I can flip and multiply. And that gives me 9 for the sum. All right, let's go to this next one. I'm going to start by writing out the first couple of terms. Again, this is a weird looking formula that I'm not familiar with, so I'm going to start by plugging in 1 for n. And I can do that in my head, actually. That just means my first term is 1/4. If I plug in 2 for n, I get 2/4, which is 1/2. If I plug in 3 for n, I get 3/4. And so those are the first couple terms. You're always allowed to do that. Remember, you just start by plugging in 1 here, and that gives you your first term. Then plug in 2. 1/4 times 2 is 1/2. Then plug in 3. 1/4 times 3 is 3/4. Do you notice these numbers are getting bigger? This is getting bigger That means if I would start by adding all of these up, the sum would get bigger and bigger and bigger and bigger, meaning it does not exist. So it diverges, which means the sum does not exist. So beware of those, you guys, okay? If the numbers are getting bigger, they're approaching infinity, which means they're not approaching a specific number. Okay, got a couple more. 3/4, 1/2, 1/3, 2/9. These numbers are getting smaller. This is 0.75, this is 0.5, this is 0.3. Numbers are getting smaller. What I need to do is figure out what's the ratio. This one's not obvious to me. Maybe it's obvious to you. I'm going to use that trick. And remember, to figure out what the ratio is, you can take the second term divided by the first term, as this should be the same thing as the third term divided by the second term. You can check any two terms. I'm going to take the second term divided by the first term, and that means I can flip and multiply, and that means I get 2/3. Okay, so let me just check that with another pair of terms. So let me take the third term divided by the second term, and that means flip and multiply, and I get 2/3. Okay, whew, that means r equals 2. And so again, I know these numbers are getting smaller. That means it converges, so I can use my formula, okay? S equals the first term over 1 minus r. The first term is 3/4. 1 minus the ratio is 2/3. That's 3/4 divided by 1/3, which is 3/4 times 3, which is 9 over 4. Boom. Okay, I've got one more to go through. That's this next one. Again, we have a weird looking formula, and it's an infinite series, so I'm going to write out the first couple terms. I'm going to start by plugging in 1 here. That means the first term is just 9/8. If I plug in 2 there, if I plug in 2 right here for the exponent, that means square the 9 and square the 8. That gives me 81 over 64. If I plug in 3 there, 9 to the third is 729. 8 to the third is 512. Had to pause and think about that for a second. Okay, what do you know about these numbers? 9/8 is just a little bit over 1. 81 over 64 is also over 1, but more over 1 than that one is. And over 1, I mean bigger than 1. And I believe these numbers, you can check this in your calculator and get some decimals, but these numbers are getting bigger. They're not getting smaller. They're not approaching a certain number. So getting bigger, that means this diverges, which means the sum does not exist. Okay? I am, like I said, going to save the repeating decimals to talk about in class. So this last section, these things and the 3 examples on the next page, I'm going to save those. But now you guys know what converging and diverging is, a little bit of a brief introduction, and how to find the sum of an infinite number of numbers, if it exists. So just one thing to keep in mind is that that is in the directions up here, if it exists. So you need to be watching out for that on quizzes and tests. That's a reminder to be looking for specific problems like this one and this one, okay? Just to watch out for that. It's like a warning sign, okay? Thank you guys for watching. Have a great night. I'll see you tomorrow.